Hello everyone, and welcome to this video on Bayes Theorem and conditional probability. This video came about because of a problem that I received from a student a couple of weeks ago, and I thought it would be instructive for us to look at it since we don't see the Bayes aspect of conditional probability quite as often. Let's take a look at the problem now and see what we can make of it. It reads like this. At a busy city intersection, the probability of an accident is 0.08 or 8%. If it is raining, the probability of an accident is 0.24, 24%. Weather records show that the probability of rain in the city is 0.10, 10%. Knowing that an accident occurred, find the probability that there was rain in the city at the time. Okay, so the first thing we should do is set up some variables. And depending on where you are on your probability journey, this probably wasn't the toughest part, I'm guessing, of the problem, but we'll see. So I wrote it like this. Let A be the event that an accident occurred at the intersection. And let R equal the event that rain occurred. So what we're given here is the probability of an accident being 8%. And the probability of an accident, given that we knew that there was rain, is 0.24. And the probability of rain at all is 0.10. Now, let me come back up here for a moment and show you something. So I'm going to come back up here. If this says, if it is raining, here's my condition. And this is the first piece of this that's potentially difficult. If it is raining, so here we're assuming that it's raining already. We're given that we're in the rain. If it is raining, the probability of an accident is 0.24. So this becomes a conditional probability. This is the probability, excuse me, this is, I'll type it in. This is the probability we know that it's raining. So this is the probability of an accident given rain. A given R. If it is raining, A given R. Because we're given that it's raining, the probability of an accident is 0.24, okay? So this piece that's underlined is this symbol. Show that the probability of rain, okay. Find the probability that there was rain in the city at the time, knowing that an accident occurred. So this is actually what we want to find is actually the reverse of the probability they give us. We know that conditional probabilities are not reversible, and that's because that it changes the sample space at the bottom of the screen. So let's continue now with the second part of this. Let's continue here and read what else we have. So now, here we are. I'm going to clear my drawings. Okay. So we know that we want the probability of rain given an accident. We also know that A and R are dependent events. They depend on each other. There's more likely to be an accident if it's rain, right? So So here I gave you the little conditional probability formula. The top is always the two events connected by and. So probability of a rain and an accident. And because we're looking for, given an accident, that's going to be probability in our denominator. So that's our formula. Now, this is where this gets a little bit tricky, because we take the top, and the probability of rain and an accident would sometimes be the probability of rain multiplied by the probability of an accident. But because they're dependent, we need the probability of rain times the probability of an accident given that it rains. Now we know what the probability of an accident given rain is because they told us. So we know this top portion. We know both terms at the top. You might think you know the bottom term. And that's where this is the next place where this gets tricky, because this is just the probability of an accident. But we need the probability of an accident when raining and the probability of an accident when it's not raining. So we need both of those terms, and we need to add them together for the total probability of the probability of an accident. So I wrote it for you over here. Probability of an accident equals probability of an accident when it's raining, or the probability of an accident when it's not raining. Okay. So now we just plug those in. The probability of an accident when raining, 0.24, is the accident given rain, times the percentage of times that it actually rains, which is 0.10. Now, this term, if you multiply it out, becomes, this is 0.024. And the other one is the probability of an accident, so 0.08, times the likelihood that it doesn't rain. Well, it only rains 10% of the time, so it would not rain 1 minus 0.10 or 0.90, and if you multiply those out, you get 0.072. Now, if you add that up, you get the probability of an accident. I should probably put that over here. Probability of an accident is equal to, and then here, same, the probability of an accident is 0.096. Now, this here is this bottom piece. So when we go to calculate this probability over here, we get the following. We're going to have the probability that it rains, that's going to be 0.10, because it rains 10% of the time. A given R, they did give us. That is 0.24. And we're going to have to divide that. We're going to have to divide that by 0.096. So if you do that, here's my line. We're going to end up with 0.096. 0.096. And if you work that out, you're going to get, as an answer, you're going to get 0.25 or 25%. So I guess we can be thankful that our first responders are out. But that's how this problem looks. Notice a couple of things. Notice that the probability of A given R is not equal to the probability of R given A. Okay? In general, they're not. Okay? Because as I said, for A given R, you have A and R at the top, which is what we have, but you have at the bottom, since you have given R, you would be dividing it by the probability. So that's one thing to note. And the other thing to note is that if you used or tried to use a conditional probability diagram, try it. What you'll discover is you don't have enough information immediately to fill in the trees. And I think that's where these formulas can come in handy in helping you to work that backwards and forwards. Okay? But I hope that this video has helped you. I hope that you learned something from this example. If you have any questions or comments, feel free to drop them below. And I will see you in my next video very soon, folks. Take care. Continue having wonderful holidays, and I'll chat with you soon. Thank you very much. Bye for now.